All right, video number 4. Let's do this. Okay, so we're solving each radical equation. So remember you have a foldable on this, and that would be a great thing for you to go through those steps and decide what you need to write down. So solve each radical equation. Remember, the first thing we do is we get the radical all by itself. And in this case, we're just going to subtract 9 from both sides to do that. And we have the cube root of x equals 14 minus 9, which is 5. And then to undo the cube root, remember we just cube it, because the cube root is like 1/3. And so when we cube it, that undoes the cube root. So we have x equals 5 cubed, which is 125. Now remember, the key to this one is you do have to plug them back in and check for extraneous solutions every time. So we take 125 and we put it back in our original equation, and we say, is the cube root of 125 plus 9 equal to 14? Well, the cube root of 125 is 5 plus 9. Sure enough, it equals 14. So the next one, again, remember our first thing we need to do is we need to get the radical all by itself on one side. Well, in this case, it already is. So we can go ahead and square both sides. Now, when you square both sides, remember that we square the 2 and the x, so that becomes 4x squared equals 17x minus 15, because the square cancels out the square root. Now, I see that I have an x squared, which tells me it's a quadratic, and to solve quadratics, I need to get everything on one side so that it's equal to 0. So I'm going to have 4x squared minus 17x plus 15 equals 0. And then I have to solve this. I can use the quadratic formula if I want, but I'm going to go ahead and factor. And since this has an a value that's bigger than 1, I'm going to use the box so that I can see it a little bit better. So we have something that multiplies to 60 and adds to negative 17. So 6 and 10 doesn't work. What does work? So like 60, 4 times 15. Let's see, that divided by 5. Aha, there we go, 5 and 12. 5 and 12. So we know that 5 times 12 equals 60, and 5 plus 12 equals 17. So this is going to be negative 5x, negative 12x. We know that those two are going to add up to negative 17x, so that's great. And then we just go ahead and figure out what our factors have to be. Well, right here, I have 4x squared, and I know that 4x times x equals 4x squared. And so then that would mean this has to be negative 3, so that 4x times negative 3 equals negative 12x, right? And then this would have to be negative 5. And now does everything work out? Yep, it sure does. Everything works out. So my factors are 4x minus 5 and x minus 3. And now we know that that equals 0. So we set each of those factors equal to 0, and we solve. So we have 4x minus 5 equals 0, x minus 3 equals 0. So we have x equals 5/4 and x equals 3. So those are our two options for our final product. And then we go back to the original equation and we check for extraneous solutions. So we start with 3, so 2 times 3 equals the square root of 17 times 3 minus 15. So let's see, 17 times 3 minus 15 is 36. And the square root of 36, sure enough, that does equal 6. So 3 checks out as a solution. Now we check 5/4. So we do 2 times 5/4 equals square root of 17 times 5/4. That's getting really messy, sorry guys. Minus 15. So 17 times 5 divided by 4 minus 15. That is 625, or 6.25. Sorry, so that is 6 1/4, which is 25/4. And that equals 10/4. And so the square root of 25/4 is 5/4. So that does not check out. So 5/4 does not check out as a solution. It comes out totally weird. So that one is not a solution. It's an extraneous solution. Okay, next one. Erase all my work so we can have some more space. All right, so this one again, we got to get the radical by itself, and it is already by itself, so we can just square both sides. We get 4, just kidding, not 4x squared, we get 16x squared because we square both of them, equals 6x plus 10. Then, since it's a quadratic, we got to get it all on one side, so we have 16x squared minus 6x minus 10 equals 0. We notice that this has a common factor of 2. So we can pull that out, 8x squared minus 3x minus 5. Okay, and then we could divide both sides by 2 if we wanted to. So we just get 8x squared minus 3x minus 5 equals 0. We're looking for a 0 there. And when we look for zeros in quadratics, we use factoring or the quadratic formula. So this time I think we're going to use the quadratic formula just so that you see another way. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so 4 times 8 times negative 5 times negative 1 plus 9. Okay, so that is 3 plus or minus the square root of 169 over 16. The square root of 169 is 13. So we get 3 plus or minus 13 over 16. So remember that means 3 plus 13 over 16 and 3 minus 13 over 16. So that equals 16 over 16 or negative 10 over 16. So we have 1 or negative 5/8. Those are our two options. Then we go ahead and just plug them back in and we check for extraneous solutions. I'm going to let you go ahead and do that, decide which one of those is our answer. Maybe both of them are. Maybe neither of them. It's possible to have all extraneous solutions. Okay, so I thought I left myself plenty of room, but I did not leave myself any room. Okay, so we solved this radical equation. Now remember, when we have radical equations like this, we have to isolate one of the radicals. And it doesn't really matter which one, but usually I would pick the one that's harder, that's ickier looking. Both of these are equally icky. So I'm going to add root x minus 5 to both sides. You get that on the other side. So remember, when you have them on both sides, you have to get 1 on the one side and 1 on the other side, because otherwise you're going to have this like nasty middle term that's not going to be fun. Okay, so now since we have them isolated, we square both sides and we get 6 plus x on this side. And then we get x minus 5 plus 4 root x minus 5. Don't forget that we have to either FOIL or use the box. Okay, this does not mean, okay, I will say it again and again, functions do not distribute. This squared does not just distribute into this and that, right? This isn't just x minus 5 squared and 2 squared, okay? It doesn't work that way. We have to multiply it out like a binomial with the box or FOIL or something like that. So we end up with this, and then we have another, here we have another radical. So we need to now get that radical by itself. So we have 6 plus x minus x plus 5 minus 4 equals 4 root x minus 5. So x minus x cancel out. 6 plus 5 is 11. 6 minus 4 is 2. Plus 5 is 7. And we end up here. Okay, 6 equals 4 times root x minus 5. Now, since our radical is isolated, we can go ahead and square both sides, and we get 49 equals 16 times x minus 5. Divide both sides by 16. We get 49 over 16 equals x minus 5. And we add 5 to both sides, and we get 49 over 16 plus 5 equals x. And then we can, do any fancy math that we need to get that into like a fraction. So 5 times 16 is 80. So that's 80 16ths. So plus 49, 129 16ths. That equals x, and then we could plug it back in. And it probably is going to work out. I'll let you do that. You don't need a whole video of me just plugging stuff in. So you plug it back in, check for extraneous solutions. Okay, next one. This one already has one of the variables, or one of the radicals isolated, so we can just go ahead and square both sides. The key is you always have to have at least one of the radicals isolated, okay? 4x plus 5 equals 1 plus 2 root x plus 1 plus x plus 1. So I just did FOIL in my head, but you could use the box method and multiply this out, right? So you're going to have 1 plus root x plus 1, that got really messy, and 1 plus x plus 1. So you would multiply it that way, but you would get the same thing that I just got. And then we have a radical still, so we need to isolate that one now. So we're going to go ahead and subtract 1, subtract x, and subtract 1. So we get 3x plus 5 minus plus 3 equals 2 root x plus 1. And then we still have a radical, so we still have to square it. Darn it. So we have to square this. So we're going to square both sides. So on the one side, we're going to end up with 9x squared, let's see, plus 18x plus 9 equals 4 times x plus 1. So again, I just did FOIL, or the box method, in my head. And then we end up with 9x squared plus 18x plus 9 equals 4x plus 4. Then I subtract 4x from both sides and 4 from both sides because I need to get everything equal to 0. So we end up with 9x squared plus 14x plus 5 equals 0. And then we could factor from here. So we're going to factor, figure out what multiplies to 9 times 5. So what multiplies to 45 and adds to 14? Well, 9 and 5. So this would be 9x, that would be x, this would be 5, and this would be 1. So this factors into, I'm just going to do it over here, x plus 1 and 9x plus 5 equals 0. We set each of those equal to 0. We get -1 and -5/9. Those are our two options. And then we just go ahead and plug them back in to see if they're extraneous. All right, I'm going to do this last one. I'm going to just skip that one right here. I'm just going to skip that because we've got just about a minute left in this video. So we already have one isolated, so we just square both sides. And when we square -1, that's what's in front of that, it's just in front of that root, we just get +1. So in the end, we end up with x minus 3 equals 1 minus 2 root 2x minus 5 minus 2x minus 5. So then we add 2x to both sides, and we get x. We add 5, and we get 2, and we subtract and we get 1. Okay, so here we are right there. Now we have another radical, so we have to square again. And we get x squared plus 2x plus 1 equals 4 times 2x minus 5. It's going to stop any second, so I'll just let you go from there, and we'll just move on to the next one.